Hi everyone, my name is Ray Maor and I'm a database administrator at Experda.com, where our expertise is improving SQL Server database performance, maintenance, and monitoring. Today we're going to talk about redundant and cleanup of all the indexes that we have. Now, sometimes our systems are very old. Sometimes we already have raw data that is. Today we're going to talk about index cleanups. That means redundant indexes, duplicate indexes, when we want to get rid of our indexes. I'm going to show you some scripts that we created to follow and see which indexes are actually used in our system and which indexes just hog up space. Now, why do we want to clean up indexes? First, storage. Index is actually the first reason why we want to clean up our indexes is because they take up storage. The second reason is that they're not really helping. For that, we'll see the script that we've created here at Experda.com in order for you to Why would we want to clean up our indexes? The first reason is storage. The second reason is performance. The third reason is because we want storage, performance, and the two main reasons why we want to clean up our indexes is because of storage and performance. Storage is because the index, just like a table, is a duplicate of information. It's stored in the database system, in the database files. And if we're not using that index in the proper way, then we want to clean it up and won't use it anymore. The second reason is performance. Indexes impact on insert statements, delete statements, and update statements. At very rare occasions, an additional index actually hurts performance by the fact that the optimizer gets confused because of the amount of different variables or the amount of different paths or execution paths it can create. For example, if we have 8 indexes on a table and let's hypothesize a very complicated select statement where all of these indexes are actually on single columns, and all of these columns are in some way in the where clause. The optimizer, while creating the execution plan, will have to think about different methods of getting the information. And when it has 8 different methods or 8 different paths or 8 different ways, it might get confused. For example, if right now we have a selection on 5 different tables, and each one of these 5 tables has 10 different indexes. So just multiply that, or multiply and see the different paths that we can have. It can come down to 5 times 4 times 3 times 1 times the amount of indexes that each of these tables have, and eventually the optimizer can get confused. When we know the different indexes are actually being used, when we have created them and we are aware of the workload, meaning the different queries that the different tables are going to receive from the different clients, then we are aware of everything. So what is a redundant index? A redundant index is either an index that isn't being used, and I'll show you the script in a second, or an index, for example, on columns A, B, and C. This is index 1. And we have another index that is A, B, C, and D. For example, we understand that this is being used, and this one is also being used. However, we can see that A, B, and C is actually inside the A, B, C, and D. What will be the reason to keep these two separate indexes? Maybe this is a very absolute old index that was created with the system, and then we upgraded it, we improved some performance for some queries, and we recreated this one. Another reason is if column D, and again, this is a very simple example, is an end varchar column or a string column. And we see that A, B, and C are integers or very short. So for example, this will only be 12 bytes, while this one will be an average, let's say 200 plus 12. So that's 212 bytes. And then we see the difference in sizes, and we understand that for particular queries, we would like to reserve this index. However, in most cases, column D is not necessarily a string value column. So that means that we can actually eliminate this column and this index and only keep this one. This is called a redundant index. There's many examples of these. We have to really understand and know. Now, don't get confused and think that this is a redundant index because B is the starting column for this index, for the key. And B is completely different than A, okay? A has to be included in the query if we want to use this in any way, and A has to be equal as well. If we want to use a range, well, that's a different topic. Do you understand? It's very important. Now, if it would have been something like B, C, and D, then yeah, we could have canceled this one and only kept this one. So it has to be not only the columns, but the column order as well. Second type of indexes that we can drop, and this is rare, duplicate indexes. No one knows why Microsoft has enabled this option, but you can create the actual exact same keys and included columns. Duplicate indexes. Again, find them. Sometimes it just exists there. Sometimes people got confused. Sometimes it's automatic systems that have created them. And the same thing, by the way, in the included, in the redundant, sometimes we see that we have these two indexes that have the same keys but a different included. So why not just do that? Remove an index. Remember, the insert, the update, and the delete statements are very, very, very influenced. Remember, the insert, the update, and the delete statements are influenced by the amount of indexes we have. It takes much more. Remember that the insert, the update, and the delete statements are very, very influenced. Remember that the insert, update, and delete statements are influenced by the amount of indexes you have. Actually adding just a column or a column or two to a different index, it's much faster than... Hello? Hello? Remember, the amount of indexes, remember that the amount of indexes you have in a table, remember that the amount of indexes that you have in a table impacts the insert, the update, and the delete statements. If you insert a single record to the table, now you have to insert it to all the indexes as well. From our studies here at Experda.com, we've discovered that adding another column doesn't hurt performance as much as the whole index does. Meaning, even if we have an index that is on a single column, the performance impact it has on the insert, update, and delete statements is much greater than adding another column to an already existing index. So cleaning up our indexes is very, very vitally important, especially on the larger tables. Meaning sometimes you will discover that you can save up half of your storage in the top 10 tables. Cleaning our indexes is fine. I highly recommend you using the scripts that I'm going to introduce you here. I highly recommend you manually check the biggest tables that you have in the different systems and also use the different indexes. I highly recommend cleaning up your indexes. I highly recommend cleaning up your indexes. You won't believe how many redundant and duplicate indexes you might have, and especially the unused indexes that I'm going to show you right now.